yeah, this is not something we had last year at all, and we managed to get a great group of people for today and tomorrow. Today's panel is about becoming an engineer and different perspectives on getting there, what it means to be an engineer, and we have a pretty wide spectrum of experiences and backgrounds. The way this is going to work is we'll have our panelists introduce themselves very briefly, and then I'll torment them with questions of my own, and then we're just going to open it up and see how it goes. So this is a really discussion, so don't be shy. And it's really meant for every level of engineer. So with that, I will start.
Oh, good Lord. Hi, I'm Andrew Greenberg. I am adjunct faculty at Portland State University, the local university. And I'm an electrical engineer by training. I started 2 small medical device companies and do some consulting work. And then I started yelling at the faculty that all of our undergraduate engineers are useless, that they are not building things and don't know how to build things, and they're not coding and they're not burning their hands. And so I started teaching the senior undergraduates, and also now help with the rocketry and satellite program at Portland State. And that's a great way to get kids involved in building things.
Good afternoon. My name is Heather Knight. I'm assistant professor at Oregon State University in robotics, and I design behavior systems for robots that operate around people.
Hi, I'm Sophie Kravitz. I work for Hackaday. It's a tech blog. And I am an electrical engineer by degree, and I was a sculptor first. So I kind of came into it as a hardware hacker.
Cool. Hi, my name is Grant Imahara. I'm an electrical engineer by trade. Former MythBuster, used to work at Industrial Light and Magic as a visual effects model maker. And currently, celebrity engineer spokesman for Mouser Electronics. Which you didn't know there was a category. There is.
Hello, I'm Helen Leigh, the token Brit. And I'm a product designer and a writer. I write primarily about electronics, and I also teach a lot in lots of different countries and in lots of different institutions at graduate and postgraduate level. And I've got some opinions about education, so that's why I'm here.
Hey, I'm Alex. I'm the secret Brit. Anyway, I do a video for Hackster.io. I like to build wearables and robots. I studied human languages in college and then helped co-found the makerspace in Ann Arbor before becoming a director of Noisebridge, when it didn't really, your job was to not do anything. So that's who I am.
Hey, my name is Mihir Shah. I'm an electrical engineer as well. I used to work at Tesla and Taser. I now work at Pardon, Royal Circuits, Advanced Assembly, and a few other fab and assembly shops here in the country. And we run a small cap venture capital firm investing in hardware type companies and some software analogous things that you guys may have heard of. So we could talk about that after.
Okay. Great. Well, thanks all of you for being here. Helen, you mentioned you had thoughts about education, and there's a bunch of different backgrounds here. What was the thing that got you to the point where you thought, hey, I'm an engineer, right?
And where I thought I was an engineer, and when I was building, when I'm building things that work and experimenting with new technologies, I'm not. I lecture on electronics and music technologies at a number of different institutions, but I also teach at a lot of informal places. So I think it's really interesting, this divide between formal and informal education. And like I learned to use an oscilloscope in my friend's kitchen. I didn't learn to use an oscilloscope at my university, and I see, I teach engineering students. And their skills are really poor. Their practical skills are really terrible. I teach creative students about different types of technology, and they don't even know what a circuit is. I think it's really interesting. So, for example, like in medical school, they're actually starting to teach surgeons how to sew to give them hand-eye coordination, because especially in intelligent kids are pushed towards these theoretical subjects constantly, and they not given the chance to to develop practical skills. So I think the way a lot of us have come up through engineering is through the maker movement and through like hands-on activities, but that's really not reflected in a lot of modern electronics engineering courses, which is a real shame. I think that both institutions and informal institutions have a lot to learn from each other in the way that they teach and also in the way that they grade as well.
Yeah. Grant, you did have a formal training, but I know that it was circuitous in a way.
It's
can
true,
you talk
yeah.
about that a bit?
Okay. So I was studying electrical engineering at USC in the second semester of my sophomore year. And it's when they hit you with all the hardest courses, Physics 3, Calc 3, Engineering Electrophysics. Still don't know what a hole is, but okay. That's a good, I actually hit that joke here. See, that's awesome.
It's the right crowd for that.
It's the right crowd. And so it is, right up. And so I was having a really hard time. And so I quit. I quit engineering. Not that I advocate this these days, but I quit and I decided I want to do something creative. So I went to the film school. And I said, I want to be a writer, but USC Film School doesn't let you in off the street. But what they did do was guide me to a mentor. They said, well, you know, Tom Holman works here. I was like, who's Tom Holman? He's a cinema professor and also an engineer, and he is the TH of THX. So I went to his office, and yeah. Yeah. So I went to his office, and I said, could I, you know, he's absent-minded professor, his office was a mess. And so I saw, this is my opportunity. I'll be his personal assistant. So, Mr. Holman, I think you need a personal assistant. He's like, great. Do I have to pay you? Like, no, I'll work for free. So I worked with Tom for a year. He took me to meetings, gave me things to read. And eventually I found my way back into engineering. And I went on to complete my courses, and I became an intern at THX for the summer. And that's what started my path towards entertainment engineering.
Cool. So Heather and Andrew, you're professional educators, ish, yeah. And yeah, I think what Helen said really resonated with me. Like, I took classes at some really great schools about engineering and didn't learn anything until I had to do it myself or with friends or whatever. So can you two share kind of your perspective at being a professional educator, how you see that kind of balancing with the really practical, just get your hands dirty side of things?
Is this thing on? Yeah, I mean, I fell in love with robots by building them. So Josh and I actually met at the MIT Media Lab many moons ago. I think you were a grad student, and I was
it's true.
lowly undergrad. But yeah, so he's old. But
that's also true.
But it was like this phenomenal place where people like mixed like art and technology, and it was really cool. And I took I went to MIT as an undergrad, so, local school. But I think of all the classes I took were not particularly valuable. Like the research experiences that I had were phenomenal, and I have a research lab now, and it's really fun to get students kind of to come up with their own ideas. The most shocking thing for me as an undergrad, because I just thought engineering had something to do with math and science, was when I realized you could be creative. And it was like a lot more like sculpture. You could kind of come up with the idea and build it. And so I feel like I really felt like an engineer. This is your earlier question, when I like just first like had an idea and then started just like looking around the room for like, okay, how can I build this? And like when you start grabbing things out of supply closets, like to like come up like to complete the prototype of this idea you just had in the last 2 hours, I think you officially know that you're an engineer.
Can I answer that? Okay. So you're gonna have to tell me to shut up too, because like
I will.
Thank you. This is my thing. So, and I'll preface it with this: what's the difference between a maker and an engineer, right? Yeah. All right. So, and this is like a religious thing, so I'm sorry, I'll get like killed later. So makers go out and they make things, and we're all makers, and it's really cool, and we love them. And some people make art, and some people make technology, and it's this thing where it's kind of an organic, like, I'm going to do it, and I don't care who I am, I'm just going to do it, right? And then there's engineers. And us engineers go through a formal, rigorous undergraduate curriculum of math and very abstract things. And then we're useless when we're done, and because we've not built anything. And so the question is, how do you put those together? How do you bring the makers into the quantitative engineering analysis fold? Because that's what they really need if they're going to do super cool stuff. And how do you push the super abstract kids into building stuff? And they've got the background, they've got the math and the physics and all that kind of stuff, but they've not built anything. And right in the middle is the coolest place in the whole universe. And I think that all these people actually sort of like, typify that, right? And that's why Teardown exists from my point of view, is that it's the cool people who are meeting in that really interesting middle of maker and engineering that is interesting. And I think that the problem is we see both sides as not being great, but it's the middle is the best part.
So, Heather, you kind of touched on the creative side of engineering and using engineering as a tool. Sophie, you are an artist also, or first even. Which one do you spend more time on now, or do you see this difference even?
Definitely identify more with being an artist, but the kind of artwork I do requires the sort of technical background. I think I'm going to go in a totally different direction since we're starting to talk about art. Everybody here's heard of STEAM, and the A in, and I have somewhat of an unpopular opinion about it, which is that STEM is really an economic thing from our government, because all the jobs that come in through STEM are the jobs that have all the money. And putting the A, which is the creative part, it's important from a societal level, but from an economic level, it doesn't help at all. So can we talk about that?
Yeah.
Yeah.
Yes. This informs, was having a thought that's very relevant here, which is about the idea of the distinction between making and engineering and stuff. I think a lot of it also comes from your ability to repurpose things and have like a huge junk pile. Like for me, I started out on an extremely low budget, being a student, being a postgraduate who had like part-time low-wage jobs. And so in order to make stuff and make my life better, I was like really repurposing stuff, having creativity through constraints. And I think that's a lot of where the art comes in, is like this ability to see a pile of crap and turn it into something magical. Like, I think that's where a lot of the making part of it comes in the self-education that we pick up from childhood, is being able to take a cardboard box and turn it into a crazy time machine. Keller and Hobbes style.
Can I add to that? Yeah. I think it's actually really important not to just talk about how to bring engineering to people who are making art, but also how to bring artistic and design perspectives to people in engineering. I recently taught on a master's module on music technology in London, and all of my students were non-technical, which was really unusual for me. But their abilities to conceptualize and create a working musical instrument within the time allotted was absolutely amazing. Okay, they didn't have amazing engineering knowledge, but what they did have is decades of user experience and knowledge about kind of the art and the beauty of a thing. I think it's really important when we're talking about bringing people into engineering to recognize that not everybody needs to be an engineer in order to have a valuable perspective. And also I think, engineering is a tool, right? It's a knowledge base that enables you to make things, right? And I think you're absolutely right. That the exciting stuff is in the margins. I think you get the most exciting things when you smush together disciplines, when you smush together people. That kind of like marginal knowledge is super rich, and it's something that we should be prioritizing and lifting up. So yeah.
The other thing about artists is the thought process is very similar to scientists, where you're just picking up some kind of idea and going with it and following your thought passion and doing whatever it takes to make the thing happen. Like what you're talking about, piles of junk. I have lots of piles of junk. I make a lot of things with the piles of junks. Yes.
Yeah, the main thing I would touch on is just how many people actually go in to any sort of even small scale engineering project, especially if you're dealing with any sort of fabricator, just because I'm from the manufacturing side. We have 400 employees between all our factories. Of those, probably less than 10%, 15% have a bachelor's degree, and of those, like 1% have any sort of engineering background. And all these people are involved in a very rigorous and like thorough process to make something even as simple as like a 2-layer board that's a connector, or all the way up to like a 12-layer 4-lamp cycle, crazy tiny drill holes, laser via, etc. type of job. And these aren't people that went to school for 6 years to study EE, but they have a very technical understanding of what actually makes a circuit board as that specific example.
Well, it's vocational in a way. I mean,
That's right.
It's skilled labor.
But there's so much thinking involved, especially if any of you guys have ever built a very complex board, how much you have to interact with the fab, and we work with you to kind of make it a reality, but how much technical stuff that goes on that is just kind of different.
Yeah. My parents are English teachers, and a big part of what they noticed is that when you're talking to engineering students, people tend to think of the humanities and writing as soft sciences, but engineers are actually some of the people who do the most writing, technical writing, doing blogs and stuff, and so separating the two is just a huge mistake.
Yeah, Fred, our technical writer at Crowd Supply, had lunch with me. He's like, "Hey, you should hire a writer." I'm like, "No, we don't. We're a technical company. We don't need writers." And I spent the next week writing poorly, and I went back to him like, "You're right. Let's do it."
Same with tech support. I did a lot of tech support, and it's the same thing.
Yeah, I've had a similar experience. Like I think I went to college for also studied electrical engineering, and didn't write basically for 4 years, and then worked for a little bit, came back to grad school, and the only thing they care about now, I'm assistant professor, tenure track, the thing that will get me the job for life after the 5 or 6 years is whether I've had publications, right? I was like, well, why did you deprive me of writing for 4 or 5 years when this is the only way to leave our legacy in research? And so it's really interesting how much time I spend with my new grad students, just teaching them how we communicate and stuff. I did want to just put a quick plug out for research, just because I think that there's there's the making, there's engineering, there's being an artist, there's but something that's really neat about I think research is that it really popularizes communities across the planet that are doing things, which I think happens in the hacker space, all the online connections and bloggage for interactive art people, that these communities of knowledge, being able to do that sort of 10,000 hours of really investing in a little topic instead of maybe mastering whole huge swaths of engineering or computer science is also this magical thing, because if you are the artist that has specialized in chatbots on stage in that then are used to then make theater performances, which is very narrow, but you can be the expert of chatbots in human performed theater experiences. I don't know, that there's something really to spending a lot of time staring at things, but also going back and forth between that local knowledge and these communities of people across the planet that is super exciting.
May I ask you and Grant, as well as people thinking about this performance and future of technology stuff, what do you see about the future of video or VR or other media in terms of how we should be educating the engineers of tomorrow? Because that's how a lot of people are picking up their skills now.
It's weird. It's a brave new world. When I graduated in '93, the internet wasn't really a thing. All we had were data sheets that you could look up on Gopher. Wow. But now, yeah, wow. But I heard that. But now, if you want to learn something, you have the vast resources of a huge community in the world, and you can go on YouTube and watch a tutorial. I used to have to subscribe to electronics magazines like Circuit Cellar Inc. and Nuts and Volts, and it would come to you. It's true story, and it would come to you every month, and you would build the project, and that's how you learned. But now it's incredible, and it's even now that we have the maker movement fueling the ability to 3D print things, to have a custom board that you designed, fabricated in a couple days. That was, when I graduated college, that was unheard of. Nobody could do that. And now, you know, it's an incredible time to be an engineer and a maker. So.
I think that's a really important point to make, is that actually the way that so I don't just teach postgraduate, I teach children sometimes as well. And it's really interesting, this switch. It's happened now that they consume the education content with video. I used to get commissioned to design curriculum for companies or countries, and it was always written, photocopiable worksheets, books, this kind of stuff. And suddenly, like a year ago, bam, I'm only getting asked to create video content now. It's just
Alex
gone.
is way ahead of us in this
like,
regard.
It's done. Like, it's crazy. And like children just consume educational content online. It's video. It's changed. It's already happened. We're just old. Like, it's true. It's genuinely true. And I think it's amazing. It's genuinely really exciting. And I would also like to put like a huge shout out to the people who, so we're kind of benefiting off of a whole bunch of tools that have been, you know, people have slaved away to, you know, like worked really hard to like in their spare time to create things like Open Fpga to allow like ordinary people to use FPGAs, people who create things like KiCad to allow us to not use, to be able to play with PCBs. You know, people like Oshpark, and I'm wearing a t-shirt, I'm not employed by them, but you know, like who allow you to kind of create 3 boards at a time. Like there's a lot of really interesting small companies and interesting makers who are working really hard behind the scenes to make it accessible and make these educational tools, because they are educational tools on a certain level, I think. Yeah, it's very exciting to see FPGA suddenly come and start being a thing.
So FPGA is a really good example. Yeah, I think we all have a perspective of what's coming. From Crowd Supply, we see it from what submissions we get in, right? Like okay, we got an FPGA board in. 4 years ago, we had one, right? And now we have a sold-out workshop because it's totally open. And so that's something. It took a few years. What do you all see is coming like that next? Right? You want to start?
You have this cool AR tool.
Yeah, so we just invested in a company in San Francisco called Debugger. It's augmented reality for PCB debugging. Not really as a plug, but more just showing where this kind of media is going. You can hover your phone over the board, and it'll essentially superimpose the different parts of the design, parsing the nets, components, layers, etc. Just as an example of how you can kind of get even closer to your design or someone else's and have a more accurate and kind of iterative process closer to that of software. When you
is it like Tron at all? It should be. If it's not, that'd be amazing. Okay.
Yeah, but even to answer your question about what we're seeing, I mean, we have over 15,000 active customers, so I see boards from every walk of life, all over the country, from big large companies, makers, hobbyists, etc. The big thing I'm noticing is like the fearlessness of engineers to just design crazy stuff and actually get it built in a reasonable amount of time. Cost we could talk about after, but for the most part, I mean, I see people without, just a single 2-person company designing 12-layer boards with Baird and Blind and like crazy designs.
What's an example of the end product that would come out of that?
It varies whether or not we do the assembly, but a lot of them are like FPGA type designs. A lot of like solo LiDAR companies and kind of like crazy stuff that we're seeing all over, not just in the Bay Area, like in Oklahoma and stuff. That's pretty awesome.
I want to see what kind of tractor hacks you're seeing.
So one of the things that I think is coming, and we're all blind to it because we're deep seeped into it, is little tiny Linux boxes, right? We've talked about Moore's Law forever. And us embedded maker people, we never get Moore's Law. We've been stuck with Atmel 8-bit microcontrollers for like ever. And then finally, these jerks finally come up with this Linux thing on a chip, right? So we've got Octavos now, and Atmel has a little thing on a chip. And it's like, oh, my design now has 8 Linux boxes in it. What just happened, right? And now like I'm talking IP instead of serial parts, and there's this sort of like, oh my God, I have to understand Linux and the stack, and oh my God. And that is kind of risen up, and it's kind of cool because we don't notice it because we're steeped in it, But I really think that's changing everything. That all of a sudden we've got all of these incredible libraries that have been worked on by open source people for so long, right? The people that we're all indebted to. And we now have access to them. It's not just Arduino anymore. It's apt-get install, robot operating system.
I have noticed it because I'm much more intuitively tuned into hardware than software, and so I'm still like, oh my god, what is an LS or whatever. I mean, it's been a while, but and I do think that that's something that we need to be making more accessible to people. Like, which libraries? Just give me a list. How do I do this thing? I don't know.
Any other thoughts?
Recently, I had the opportunity to interview Massimo Banzi from Mauser, who is one of the creators of Arduino. And I asked him, well, what do you think is the reason for Arduino's success? And he says, it's two things. One thing is to make it simple, to make the interface simple, to enable people to not feel intimidated by using the product, using the thing, to free them up to have an idea and to say, oh, that wasn't that hard. That's why the first example is Blink, and it's super simple. You can do it in 2 lines of code because you want to give them that immediate gratification. Like, I did something. I made it blink. Let's see what else we can do. The other thing was that it was open source. And so the idea that you have this simple thing that's incredibly powerful, that is also available to many different people in many different ways, that you don't lock down that technology. That idea of being able to share it, I think, was really powerful. So when I think about what's coming and the kind of tools that we're going to see, I think that that's likely what we'll see is more things that are simple, that are open source, that appeal to people, that get them up and going, and maybe not just microcontrollers, all kinds of technologies.
Can I disagree with you?
Absolutely. You get your own microphone.
All right, cool, thanks. Well, I mean, I think that Massimo is right in that the ease of the Arduino, especially compared to what went before, was really important. But I think the second most important thing wasn't the fact it's open source. You talk to most people, they don't know what open source is and they don't care what open source is. I think what set Arduino apart is their documentation. Documentation is key. It doesn't matter how amazing your single board computer is. If you've got rubbish documentation and a poor user community, it's going to fail. One of the boards I teach with most now is one developed by the BBC called the Microbit. And the reason why it's becoming so popular is nothing to do, it's because it's really cheap. It's $9. You can do a lot with it. You can be creative with it within 15 minutes. I mean, it's a genuinely, they've thought about it as part of the ecosystem of teaching below 16-year-olds. It's very targeted. And I think their documentation is excellent. Their getting to blink, that is an incredibly important thing. But I think, the thing that the Pi did really well, and the thing that Arduino did really well, and the thing that Microbit's doing really well is documentation and user support for non-technical people. I think it's really exciting.
Cool. If I can add to the Arduino fireside stories. What's interesting is that I got introduced to Arduino as an electrical engineer, not from engineering at all, but because people were using it to make interactive art. So one of the things that I was really excited about was its integration with processing, which was basically just something that you could make visualizations with really easily. You can make things go on fire and have particle generators and so it was really great for making interactive art stuff. So I don't know. I think one time when I was at JPL, I managed to get 10% time working with this guy, Dan Goods, who's the unofficial artist of JPL because the Congress got upset when they said they had an artist. So now he's listed as a designer or something. But yeah, we made this installation at Caltech for this AI conference where people could use their cell phones to just the bright like it would just detect the color, and so they were controlling asteroids, and they could make them crash into each other, and then we made them explode with like the little particle things, but in like fire colors, right? And so that was like how I first got into Arduinos, and they only got integrated into stuff like research, like labs later, like after the artists had sort of taken them over because they were so accessible. At least that was my random perspective. But yeah, the first time I ever taught anything was when I was in LA. Like I taught at this little place called Machine Project, and a 2-day workshop for artists to learn to use basically Arduinos and simple sensors. And yeah, artists do cool things. I just wanted to share one project. My favorite project was like this, so imagine a mechanical curtain, okay, right? Like that is like this wide, right? And so it detects a person walking by and just chases them so they can't see inside the building. Like so freaking cool, right? Anyway, so.
Sophie, I want to hear from you.
So I'm going to go down a science fiction path. What I think is coming next is in the new chip architectures. So we're getting tools that are becoming available to, I personally haven't worked with any of the new RISC-V architecture tools yet, but these things are becoming accessible to where we can design new silicon. And there's a lot of talk about, as Moore's law slows down, are we going to be coming into, well, there's the science fiction thing, which is injecting chips directly with DNA, which probably isn't going to happen. But what probably is going to happen is more of a quantum approach to chip design. And I think that's going to be really interesting as to what we're going to see. Probably, I think in the next 3 to 5 years, we're going to see that.
Cool. Yeah, I think you mentioned RISC-V and the Linux boards. We see the same thing, basically. Smaller Linux, RISC-V, FPGAs, educational material, like getting wrapped in educational material is definitely happening. Going back to the art engineering false dichotomy, you can tell I'm biased. One thing that's happened a lot, or I've seen a lot of, is folks saying, "Oh, well, this is creative, so you might not understand it." And I'm like, I just spent 3 months creating what I think, or as elegant of a thing as I could, and to me it was just all creative energy, right? So, Grant, you're on both. You're very much in the creative industry and the engineering industry. Tell us your perspective on that. Like, which is dominant or shaping the future?
Yeah, I think my perspective. So I'm Mauser's celebrity engineer spokesman, but the day job is working at Disney Research. I'm a consultant there, and yeah, what's that?
That's not fair.
Not fair. Okay. Well, yeah.
Too cool job.
But the whole charter, the whole charter that we have is to take fringe technologies and play with them and see if we can come up with something that's cool and unique. And so, for me, it's always been it's not been a line necessarily. It's been a very blurry kind of path between engineering and entertainment. And I always wanted to have some creative aspect to my career. And when I was at ILM, I was using microcontrollers inside of the Energizer Bunny, and R2D2 has a microcontroller in there. And so I would always be walking with both feet, one foot firmly planted in engineering, one foot firmly planted in entertainment. And so for me, it's never been a choice between the two. It's always been finding the way to integrate both of them together.
I just want to add a little something, which is just not to forget about collaboration. So if you're an engineer without much artistic background, or the other way around, I think it's really important to have collaborations where you learn from each other. I think most of my major projects that I do for fun or for my own, learning are a collaboration one way or another. And it's a really nice thing to do is to approach somebody whose work you admire and suggest a thing to work on together. And that's an amazing way of informal learning, but it's also a way of expanding the reach of both art and engineering is by collaboration. That's how we grow our skills and community. So,
I think the right phrase is art is the gateway drug to engineering. And the reason I say that is because we're all kids and we don't want to become engineers when we're kids necessarily. Like building stuff is fun, but you don't think of yourself as an engineer. But then something gets you, right? And whether it was the moon landings if you're really old, or if it's like watching a curtain chase you and not let you look in the building, it's kind of magic. You don't know how it works. It grabs you and you're like, holy crap, what the hell is that? And then the engineer takes over and you start to say, well, okay, how can I do that? And we know it's stepper motors and cameras and things like that, but the sort of the entertainment of seeing a Sphero robot roll across the ground is really the thing that kicks off the engineering. You said creative, spans the art and the engineering, and it is a false dichotomy because it kind of goes right into each other. Whether the output is some oscilloscope versus an art project, it's not irrelevant, but it's the end product as opposed to the creative process that gets there. There's something driving the engineer or the maker to do that.
That's kind of what's so cool about the whole badge life movement is people getting into PCB art through just being like, oh my god, look at this amazing cool PCB. Like could I do that? But then you open up Eagle and their example project is an entire Arduino, and you're like, how do I? This is not a feasible thing for me to do. So I've been working on this thing called Charmware that's just like a really simple PCB introduction that people can tweak and stuff, and like, but going off of the whole PC or badge life movement as a way to get the shiny blinkies in front of people, which is kind of what he is as well, so that then you get excited to build something and it seems not as bad.
I bet you have questions. So let's open that up. Can you use this one?
Sure. Who has a question?
We covered it all.
Yeah. You did. You pretty much did. So FPGAs was mentioned in there somewhere, and that's something that I'm personally excited about. I have a background in English and French literature from many, many years ago. However, I now work for Intel, and I am getting my master's degree in ECE at PSU. So one of the things that really strikes me about Verilog and about FPGAs in general is you're forced to change from thinking about life in terms of C and that structural procedural way of thinking into a more abstract way of thinking, because things are happening all at the same time. So how do you see that, the proliferation of cheap FPGAs as, like, I remember the logo turtle. I don't know if, I'm sure some of you remember the logo turtle. That was what grabbed me and was like, oh my goodness, that looks like so much fun. How do we take something like Verilog and FPGAs and turn it into a logo turtle? Something along that line.
I don't think those are really I think FPGA doesn't need to be logo turtle. I think FPGA is, I mean, even though it's becoming a lot more open, it's still going to remain a fairly niche interest. Not everybody needs to create their own board. So I think whilst making I think the open FPGA movement is a really awesome one, and I think we should be doing, it's just really exciting to see that technology come to maturity in the hacker movement. But like, as amazing as Logo Turtle is, not everybody needs to know how to program an FPGA. So I think it's okay to have so it's okay to not know everything.
I wonder if someone is going to develop like a wrapper for Verilog that's just going to be like, drag this in and this creates 8 I/O. And then, I mean, just with the cheap hardware, there's no reason why kids can't be like, hey, I'm going to create a chip that powers a TV, or I'm going to make a cell phone for myself. I mean, we've seen things advance so quickly. I could totally see like kids being like, oh, I'm going to make a phone. My dad won't let me have one. Ha ha.
Yeah, FPGAs are awful and terrible, and they're almost as bad as Haskell, right? And the thing is that we won't make the tools that are the next the next C, right? Because we're not thinking that way. And so you're exactly right, which is, how do you think about an FPGA? Because it's terrible if you think procedurally. I don't know. I like the graphical design language or something like that. It just comes up. Someone's going to do that, and it's going to be great. But I also want to say that's not the point, really. We think FPGAs are cool because we understand them. SDR is super cool and scary, right? Like CDMA is magic. And no kid is ever going to say, I saw an SDR and that's going to make me do it. But some kid is going to say, I want to do my own deep space network in my backyard. And that's going to lead them to the SDR, and that's going to lead them to the cheap SDR and to GNU Radio, and then to a Lime Mini, and then to a Lime, and then to the XHTC, whatever the hell it was. And it's this progression, right? And so one of the interesting things is, what are the tools that we can't see that will help that transition? I don't know if we can see it until it's too late and everybody's using them, like Arduino. My first experience with an Arduino was the horror of how terribly it's laid out, and like, who the hell made that, like, the whole pattern for that, right? And I totally didn't get it. I still hate them, for the record. But but they've recreated my youth. That was Heathkits, right? You remember Heathkits? That died, and now we have something much cooler. And so it'll be interesting to watch that.
I forgot something earlier that from my talk with Massimo Banzi, and it was modularity was also one of the keys. And I think that, mentioning how will our tools evolve, I think that modularity is going to be very important. And when I was first getting started in electronics, if you wanted to add an ultrasonic sensor, you bought the sensor, and then you had to create the circuit on a breadboard to interface the sensor. Now, modules exist. You literally plug and play. You plug it right on top, a couple lines of code, bam, you've got an ultrasonic sensor. And so having a toolkit, a modular toolkit of things, because I think these days, every project starts with an idea. Like, wouldn't it be cool if? And then the next thing you do is go to like Adafruit or SparkFun and say, okay, what things can I pick out and put in my shopping cart to enable that? And a lot of them are there. And I think that going forward, you're going to see a lot more modularity, and not just physical boards, but software-based things that you can plug and play and make something happen very quickly, very easily.
All right, next question.
Hi, I'd like to follow up on a question I asked Andrew Greenberg last year. Are the OreSat ground stations running on open source computers yet?
Mic drop.
Sorry. So that is a veiled reference to the Raspberry Pi, right? And this is actually an interesting question. I won't go into it because it's that we're talking about, but Raspberry Pi is not technically open source, and so, but BeagleBone is. And I have to say, we've talked to Jason Cridner of BeagleBone, and we are in talks about making sure that the open source ground station is in fact actually open source. And hunt me down later so I can yell at you. Thank you.
All right, next question.
Thanks for all sharing today. We're at TEARDOWN. Can you share some examples of things you've taken apart that have inspired or gotten you excited in your engineering or maker lives?
Lately, I'm really excited about solar power and getting people to demystifying it for people so people can build more solar stuff. It's really cool. I took apart these little $3 solar and crank powered flashlights from the computer store, and all they are is it's got a switch, it's got a couple diodes feeding from the crank and the solar panel into the battery stack. There's literally no rectifiers, no regulators or anything like that. It's just like batteries, crank, solar power, switch, and then LEDs. And it's wonderful. Like, as a little tool, I converted a PCB badge to run on it, and now I want to make a little breakout like SAO holder that runs them on solar power. It's gonna be fantastic. And I think that that's like one of the big things is that the Earth is dying, we need to fix it, blah, 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 you know. And so getting people to understand that solar power isn't that complicated and things like that is really exciting for me.
I mean, less flashy than that. My first thing I took apart was like a toaster, literally a toaster. It stopped working, and I don't know, for some reason something compelled me to open it. It was like a cheap toaster, and I took it apart and I almost died because I didn't check the high voltage part. Clearly I didn't, I'm here, but it was a cool experience in analog electronics. And then I grew up around PCBs my whole life, just because our family, we've had like some other board shops and stuff forever. So I grew up like in the factory, but I didn't know what a capacitor was until I was like 16. Because again, no one at the company is an engineer. We just build the boards. So after the fact, kind of intertwining the two worlds has been a pretty interesting experience.
Something that came to mind was I did a whole project on doing educational robotics for a company, and it was extremely boring. If I see another line following robot in my life, I might kill myself. It was so dull. So I decided to take it apart and think about constructing something completely different. I really enjoy looking at really complex technology and thinking about how I can create something with kind of the same functionality, like a shitty version, essentially, of really complex, expensive technologies. You know, I'm like, how can I do that for $10? You know, that's something that really amuses me. So I made a really, really awful, but everybody loved it, shitty robot unicorn, which didn't go in the right direction. It was made of cardboard. It was made of 360-degree servo rotation motors, so it never went in the right direction, and they were gesture controlled as well, so you controlled it like a horse, like by shaking the reins and then steering. So that was a real fun hack, and I got more joy. And I made a herd of them, obviously, and took them to various events, and we raced them. And like I got way more joy and way more information out there about robotics than I did in the entire. Unfortunately, I didn't get paid for it, but like the one I got paid for, like I just saw it go into this dustbin of like sad lesson plans, and I was just like, so my robot unicorn, even though it was a crappy hack made out of a cardboard box, you know, then it was just way more engaging and way more exciting for people. So that was my stupid hack.
Currently, I'm working in research, and the thing about research, and particularly sort of fringe technologies, is that you often have to tear things apart to get the thing that you need. And how I know that I'm on the right track is the thing that I order from Amazon or some other supplier has safety features that are specifically designed to prevent me from what I want to do. So I like to say I void warranties professionally based on my experience. I'm still here, so I'm good.
One of my first electronics projects was I took apart my couch and reupholstered it with heating wires. So I had to take apart a few heating blankets. And to your point, Alex, saving the environment, and this is quite a long time ago, probably like 2005, 2006. I saved $110 on my heating bill over the course of the winter. I live in New York, so it's like 6 months. And and that was a pretty great project. I did it in high voltage wires because that's how the heating blanket came, and then I reupholstered it a few years later with low voltage heating blankets.
That's amazing. I hope you like sewed on one of those special plastic tags, being like caution. I guess like the most joy I got from taking something apart semi-recently was like we have a bunch of like robot chairs that we've made kind of inexpensively from IKEA chairs, like a Nito bot vac and like some connecting hardware. And the way you reprogram the Nito bot vac is you like take off the dustbin and you put all the electronics in the place where it would normally store the dirt. But the dustbin sensor just beeps incessantly, and it's really annoying, and like you can hear it at night. And so like the last time I took a robot apart, it was just to cut the goddamn wire. And they're so quiet right now. It's so great.
Everything should be taken apart. And so I like the phrase aggressive curiosity. Everything is wonderful to take apart. I can't think of one thing that wasn't fun. We just got a Wi-Fi based watering system for our house, which was like $60. And like, this is science fiction because like, 10 years ago, that's not a thing, right? Like I held the Wi-Fi card 20 years ago. Sorry, I'm dating myself. You held the Wi-Fi card carefully because it was like $300. And it was so cool because it's a megabit per second. And now it's like, it's $60 and it's in my damn watering system. And so I took it apart and it was adorable. It was a little SP and it was really terrible wiring and like crappy batteries and all this kind of stuff. And it was like, oh, look at this. You know, it was just, it's kind of neat. It's heartwarming. And yeah, the real trick is to not kill the kids before they figure out what they're doing. Yeah.
Yeah, mine was pretty domestic. It was my dishwasher because it wasn't working. And so I've completely disassembled my dishwasher a few times now. I know it pretty intimately now. And it's an amazing machine. I mean, it's stupidly simple, but mostly reliable. And what I want to do is put a camera in there to see what's going on, so I don't have to take it apart anymore. But then that brings up, it's totally isolated, right? You can't run power in there. There's no lighting. It's really harsh conditions. So now I have this challenge for myself to take video of the inside of my dishwasher.
Next question.
I want to bring us back to I think a comment that Sophie made earlier in terms of the when talking about the false dichotomy between arts and engineering, it still remains that there is a actual economic division between the two. As an engineer, we can take our hobbies into the arts and afford to do so, and it still remains that a lot of people who choose art as their primary profession, or I mean, even anything non-engineering, biology grad students, for example, might be struggling to find a profession that could, lead them into something else. And everyone on this panel comes from a very unique sort of almost don't fit in a box type of background. I was wondering if any of you had any comments about what is the thing to do here for those of us, in privilege of being in engineering. Should it be to bring more people into engineering? Should it be exposing, or trying to meld the different fields? All of you have very unique experiences, and was wondering if you had any thoughts.
Yeah, I think that's an interesting question. One topic that didn't come up earlier in our conversations was, why do we build what we build, and like what should we target towards? I teach ethics and social issues and computer science class in the fall, and with like juniors, undergrads. And it's like, if you think about the history of being a technology designer, like engineers are called engineers because they used to design engines. And like some other entire entity came up with the idea of, we need this train and here's where it's gonna run, and like here's where we're gonna run the lines. And so in terms of the role that we can have, like as semi-privileged technologists or whatever, I think that one role that we really need to consider is that we are not only the people designing the engine, but we're also the ones choosing where to lay the tracks and what engine to actually build. And so one thing that I think would be a great part of whether it's self-education or official education is this training to actually critique what we're actually creating, which is something that art actually has quite a lot of. Like, they bring it into a forum, like, not like, is this the best technical solution, but like, is this a design like worth creating to begin with, and like how can this impact the world, and if it's a little iffy, like, well, how can like first uses of a technology can change what happens afterwards. So like, what are the best way to illustrate like an application that could inspire other people in the future?
Relating to what you were saying about not staying in your own sort of bubble, but also this reminds me a lot of coming up in the hackerspace and makerspace scene. So like I used to use them, like that's where I learned pretty much everything I knew for a number of years. It's where I got access to tools and to materials that other people were getting rid of and things like that. And now that I have a workshop in Hackster, like in the studio, and I have some tools at my house as well in my tiny bedroom, I don't go to Noisebridge as much. I used to teach a lot of classes, and I'm trying to get back into that community because that's something I can do. I can pay my monthly dues and help support the hackerspace so people can use it. I can teach classes and help give give away, like as a person who works in a tech company, I get tons of free stuff. And you know, sometimes that stuff just goes to waste or sits around for years, and I can redistribute that and stuff. Like those are things that we can do to help, like with hands-on learning and sharing our expertise, all this good stuff.
I also came up in the hacker and makerspace, and I would echo what Alex was saying. I think it's really important as a community that we support our hacker spaces and our makerspaces. They give access to tools and access to informal learning to people who wouldn't normally get access to those. People who didn't go to engineering school, or people who, just work a normal job and can't afford to take 3 years and whatever you pay in school tuition. My God, like ridiculous. They can't afford to do that, and I think these things, hacker spaces and maker spaces are really, really important, whether you use them or not. I think you should probably join your local one and pay like $40 a month or whatever it is. It's really important, and teach a class there. Like teaching's incredibly rewarding. I think teaching at a hackerspace, supporting your local hackerspace. And also, if you work at a large institution, I think something we have more of this in Europe than in the US, are paid residencies. I think, and also paid internships, because it's all very well and good to go and do it, go and get an internship, but actually most people can't afford it, so you're already self-selecting. So there's if you're offering a residency and you're only paying $1,000 for 4 months, naming no names. There's only going to be a certain selection of people who can afford to do that. So I'm about to go and do a residency for my music technology pieces in Denmark, and they're paying me a living wage and also my transport and accommodation to get there, and that's an EU-funded thing. But I think within these big institutions, the big technology institutions, offering proper residencies that are properly compensated and will allow you to pay your rent is really important, and supporting hackerspaces also,
My personal mission is to show the world how cool engineering is. And we're just starting to discover it. True story. 1988, I was graduating high school. I went to speak to my guidance counselor to help me select what my career is going to be. She said, what are your interests? I like electronic music and making things. And she's like, oh, perfect. You should be an engineer. You should be an engineer. And I was so confused, because I didn't know what an engineer was. And I was not a totally isolated, I was just a typical high school kid. I thought she meant train engineer. But now we have the opportunity through content on television, online, on YouTube, to spread the awareness of what we do and how cool it is. And I think that, the number one sitcom on TV is about two physicists and their engineer buddies, Big Bang Theory. It's a unique time. It's a unique time, and I think that just now people are starting to discover that designing things and building things, which is what we as engineers do, and solving problems is a really cool and valuable skill.
Grant, what do you have against trains?
With that, we're already over time. Thank you very much, all of you, for being here and sharing with us your perspectives. Let's give them a round of applause.